everyone. So like 2 or 3 years ago, I made some videos going through a few studies that talk about the carry weight capacity of horses, and I posted them on TikTok, which is really a bad idea because they should have been posted on YouTube because they're definitely long form content, not short form. So um, I decided just to download them and quick splice them together and post them onto YouTube. So that's what this is. This is the first one um, that I did back in 2024, I think. Anyway, there was one section of the video where the audio would not download. I don't know why. So I did have to go through and do a voiceover reading my own captions. So you can probably figure out when you watch it which one that was. But if something's a little extra confusing, that would be why. So, anyway, I also put the summary first this time instead of at the end. So if you get through the first 15 minutes, you'll have gotten all my viewpoints on it. If you want to know why my viewpoints are what they are, that's what the rest of the video is for. So, thank you. Enjoy. I hope it is educational. And to anyone who watches a full hour of this, thank you. Hello everyone, as promised, we are going to start going through and looking at some of the studies behind the carry weight capacity of horses and the 20% rule. Again, 20% rule is the rule that states that a horse should only carry 20% of its body weight. So this is the first one we're going to do. It's a 2008 study by Ohio University. Evaluation of indicators of weight carrying ability of light riding horses. This is a 2008 study by Powell et al. That is referenced a lot in other studies and is one of the ones that I have seen used frequently when talking about the validity of the 20% rule. The evaluation of indicators of weight carrying ability of light riding horses. This is that 2008 Ohio study that a lot of people reference when talking about the horses should only carry 20% of their body weight rule. You just want the summary of why I think this study is questionable. Here it is. So essentially this study, and you can see it in this abstract, this study was really only designed to answer whether or not there was a relationship between cannon bone circumference, loin width, and horse height, and how much weight a horse can carry. That's all this study was designed to tell us, was if there was a relationship there. Once they go through everything, they use 4 treatments, etc., etc. Once they go through everything and you get down to the discussion part, all of a sudden they're discussing the carry weight capacity of a horse and what the carry weight capacity of the horse is. This study was not designed to answer what the carry weight capacity of a horse is. It's not designed to answer how to find the carry weight capacity of a horse. It's not even designed to answer how the loin width, cannon bone circumference, and height can be used to identify the carry weight of a horse. It does not answer any of those questions. It only answers whether or not there's a relationship between those 3 factors and how much a horse can carry. And yes, they did find a small but relatively significant relationship between those. So yes, the wider the loin, the larger the cannon bone circumference. It appears that the horses in this study showed less signs of exercise, of getting a workout, when they had wider loins, larger cannon bone circumference, and were taller. That's it. Those are what the results that matter. For some reason, these researchers also decided to discuss how this study leads to a recommendation of the 20% rule for horses when it doesn't. In regards to the carry weight capacity of a horse, what the actual data shows is that unconditioned horses, because all of the horses sat for 4 months in a pasture, they were not in regular work when the study was done, unconditioned horses can ride for 45 minutes at 25 and 30% of their body weight, carrying 25 and 30% of their body weight Sorry, I had to rephrase that to make sure I was phrasing it accurately. So what the study actually showed was that horses, unconditioned horses, riding for 45 minutes at an intermediate level, so walk, trot, canter, both directions, but not like PFs, passages, anything crazy. Walk, trot, canter, both directions. Unconditioned horses rode at a walk, trot, canter, intermediate level for 45 minutes, and at 25 and 30% of their body weight for those 45 minutes, they showed signs of moderate exercise by judgment of the amount of plasma lactate in their system, serum creatine kinase, heart rate, and that was it. Using those 3 factors, they were actually able to ride up to 25 to 30%, and it was only about a moderate exercise. Now, I'm using the term moderate. That's not the researcher's term. I think it's more mild. They're saying other people would disagree, so I'm splitting the difference and saying a moderate amount of exercise. What they found is that the horses were sore at 30% of their body weight, showed muscle soreness 24 and 48 hours after the exercise. They also had elevated levels of serum creatine kinase and plasma lactate. If you know anything about sports biology and exercise biology, plasma lactate and serum creatine kinase are the indicators that humans have in our body that our muscles are building, and the muscle soreness comes from the micro tears within our muscles that are then healing to build more muscle. So, at 25 and 30% of their body weight, unconditioned horses, when ridden for 45 minutes, showed signs of a moderate workout that would lead to muscle building and conditioning. That's what the data showed in this study. What they claimed is that the 20% rule is a good recommendation. The data does not support that, and the study design does not support that. And that's why I don't think this is a good study to reference when talking about the 20% rule, and why this study does not show that the 20% rule is a good rule to follow when looking at your horse's carry weight capacity. So, that's the summary. If you want all the nitty-gritty, I have 6 parts of that too. So this part right here is the abstract, and in general, in the interest of time, I probably won't talk about the abstracts too much because they're essentially just summaries of the study, talking about what the question of the study is, the basics of how they addressed that question, and the summary of their findings. This is something that someone would use if they're going through and trying to do a review, that they're going to go through and read these abstracts to find studies that have to do with what they're talking about. But I want to talk about it briefly here, and we'll talk about it more once we get into the intro, because the first sentence, to answer the question of whether horse height, cannon bone circumference, and loin width can be used as indicators of weight carrying ability in light horses. And then they talk about how they did the study. But the actual question that this study is aiming to address is whether or not there's a relationship between the height of the horse, the cannon bone circumference, and the loin width of a horse, and its carry weight capacity. It is not aiming to address what the average carry weight capacity is for horses, and this is very important. And then if we go lower, it ends with that their findings were that loin width and cannon bone circumference are related. So, in conclusion, the data suggests that horses with wider loin and thicker cannon bone circumference become less sore when carrying heavier weight loads. So their initial question was not, what is the average carrying capacity of horses? It was, is there a relationship between horse height, loin width, and cannon bone circumference, and the carry weight capacity of light riding horses? To which they found, yes, there is a relationship. Okay, so, I'm going to move on. So this next part is the introduction, and in the interest of time, I'm not going to talk about it too much as well, but essentially the introduction is just the part where you summarize prior research on the topic that you're writing an article about. So in this case, for these guys, they talked about the cavalry manuals that showed that that recommended 20% of horse rates. That wasn't like a study or anything, it's just old 1920s U.S. cavalry manuals for horse weight. And then they talk about a study of endurance horses, primarily Arabians, that showed they could carry up to 30% of their body weight for 100 miles. And then a follow-up study that found a relationship between the horse's weight and cannon bone circumference and whether or not the horse completed the endurance race. They also briefly talked about the amount of bone that a horse possesses being used as a method to determine their carry weight capacity. There's been multiple studies on that one. The one that they reference, that they talk about and summarize, they mention that it does not address the mineral content of the bone. So they give a recommendation of a certain bone circumference to a horse's weight. So, i.e., you could take an idea of what that bone circumference is and get an idea of what your horse's ideal weight is. However, that study did not address the mineral composition of those bones. So, are those bones actually nutritionally sound, essentially? And then they briefly talked about the conformation and acknowledged that the conformation of a horse really makes a big difference in how much they can carry and what that carry weight capacity is. But again, remember, the question that we're talking about is not what is the carry weight capacity of a horse, but is there a relationship between the three factors that they mentioned and the carry weight capacity of a horse. So they talked about and acknowledged the conformation of it all, and then they talked briefly about plasma lactate concentrations and horse and heart rate are reliable variables when adjusting the workload of a horse, and that the serum creatine kinase has been used before as an indicator of muscle damage. If you don't know, so just some brief background information, plasma lactate concentrations and creatine kinase are used in muscle building, and so the plasma lactate is in humans too. When you work out and you build muscle, there's going to be higher amounts of plasma lactate and creatine kinase in your bloodstream. So when we're talking about these as evaluate the workload of a horse, it would do the same thing for a person. It's just saying that this is when we know they're getting exercise. Okay, so now we're getting into the nitty-gritty of the study, the materials and methods. So for the horses, they used 8 mature horses of light riding type, 1 mare, 7 geldings, 6 to 18 years old, weighing 39 to 625 kilograms. This part's important. All horses were used as lesson horses, but had been pasture-rested for a period of 4 months before the study. This makes sense. You want horses of relatively equal conditioning if we're exploring the relationship between loin width, cannon bone circumference, and height to their carry weight capacity. Because having differently conditioned horses adds another variable into that exploration of already 4 variables. So they were pasture rested for 4 months, so they were not overly conditioned as far as workouts go. The horses were housed individually in 4x4 stalls. This is basically just going to talk about how they took out all of the other variables. They were all housed in stalls of the same size. They received the same food. They received the same amount of daily turnout. They all had access to water and salt blocks, and they were the horses were weighed weekly to keep track of any weight adjustments. This study design, that first paragraph is just kind of talking about how they ran the data analysis. If you don't know about data analytics, I don't really see any red flags. So far, I've seen no red flags. Everything looks good. Okay, so before the start of the study, they took the body weights of the horses. Perfect. They measured cannon bone circumference, loin width, etc., etc. Perfect. They talked about specifically where on the horse it was measured. All that's a green flag. Width of loin, perfect. And then 24 hours before and 24 hours each exercise test, the severity of muscle soreness and muscle tightness was graded by the same professional animal massage therapist. So before and after the test, 24 hours before, 24 hours after, They brought in an animal massage therapist that worked on the horse to see if there was muscle soreness and graded the muscle soreness on a Likert type scale. So a Likert scale is what we use in humans to grade muscle soreness. They talk about that, and then they had it adjusted for horses. That's all fine. I see no red or yellow flags at this point. They used a test. All the horses were in the same size arena, and they had a preliminary warm-up consisting of a 5-minute active walk, and they get very specific of how many kilometers at how many meters per second each horse moved. Sorry, kilometers. And on each side, so half and half, etc. Okay. And then they also recorded environmental temperature, relative humidity. Perfect, all green flags. And then before each of the tests, they recorded the rider plus tack weight. Again, fine. They did, instead of using different sized riders, they used 3 riders, and then they added weights to the saddle to get to the different treatments of 15% of the horse's body weight, 20, 25, and 30. Okay, so we are over here, about halfway down, and they talk just about how they used an adapted saddle to add weights. So they are looking to see how much of plasma lactate, creatine kinase, and what the heart rate is of the horses when being ridden at 15% of their body weight, 20%, 25, and 30, to see if horses that have larger cannon bone circumference, loin width, and a height have less of a reaction at higher body weight percentages, to see if there's a relationship between those. That's all the study is trying to do. And then here's the last part of their methods section, which is just talking about, so in that other bit chunk up there, they discussed cantering lead. They had one of 3 experienced riders that were told to ride as smoothly as possible to avoid any interactions with the horse or changes in how the horse would ride, etc., etc. And then they talked about the specifics of what lead the horse was supposed to be on, like the canter lead and things like that. All good things. I, once again, have seen no red, yellow, or orange flags at this time. Then we get down to this section right here before the results, where they're talking about how they measured the heart rate, respiration rate, and the things that they measured. So they measure heart rate, respiration rate, and rectal temperatures immediately before and immediately after the exercise, and then they took blood samples before exercise, immediately after, 10 minutes after exercise, and then they analyzed those for plasma lactate concentration and serum creatine kinase activity. And then they just talk about how they analyzed the blood samples, what analyzers they used, kind of thing. And then they took more samples of the blood to look at the plasma lactate and the creatine kinase 24 and 48 hours after the exercises. And then they also kept track of the work rates in the trotting and canter phases of the exercise test for calculation, to look at the relationship between oxygen uptake and work rate. And then all data was given. This just talks about how they gave the data, what sorts of analysis they used, Latin squares, they did their analysis in SAS, linear regressions, all that stuff. If you know anything about data, that section is going to be interesting to you. If you don't, it's going to be a lot of words you don't really understand. And p-values of less than 0.05 is considered significant, and that's just kind of a relatively arbitrarily decided blanket across many, it's the same in psychology. 0.05, less than that is considered significant. More than that, not so much. They also note that if they had a p-value of less than 0.1 but higher than 0.05, they did investigate that too. Okay, so now we get to go to the fun stuff, which is the results. So, again, I probably won't dive too much into like the specific results because it's a lot of very specific numbers. But there were no weight changes in any of the horses. They controlled for environmental temperature and humidity data for the exercises. They found that the work rate, a significant work rate was found when horses carried 25 and 30% of their body weight. Heart rates before the exercise did not differ significantly amongst different weight percentages. Heart rate, respiration rates, and rectal temperatures differed a little bit more when they carried 25 to 30%. And you can see that in table 2 up there. So, actually, I think you can see the heart rate down there. That's just the temperature and humidity. But what you'll see is that the temperatures were a little bit higher at a higher workout rate, which is not uncommon. This is a known thing. It happens for everybody. And for horses. So none of the temperatures or heart rates got into a place where it was dangerous for the horse. And they all returned back to normal within, I think they said an hour, which I'll get down to that. But within an hour, their heart rate and temperatures were back to normal after the exercise. The average plasma lactate concentrations before exercise did not differ. The plasma lactate concentrations immediately after exercise and 10 minutes after exercise were lower when the horses carried 15, 20, and 25 compared to 30. So that means that somewhere between 25 and 30%, because we don't have those middle, we only had 25, 30. So 25, 20, 15, not significantly different. 30% of the horse's body weight was when we started to see a significant difference in the plasma lactate. But again, this study is designed to look at cannon bone circumference, loin width, and height. So this is just basically they're reporting the data that will then be analyzed more to relate to these other things. So this is just basic raw data. The serum creatine kinase activities were higher immediately after exercise and 24 and 48 hours after exercise when the horses carried 30% of their body weight. The mean percentage of change in muscle soreness plus muscle tightness when measured 24 hours before and 24 hours after exercise was greater in the 25 and 30. So essentially horses were just more sore after carrying 25 and 30% of their weight versus when they carried 15 and 20. And then here's all their tables, but right down at the halfway through, they did mention that when related to the cannon bone and circumference and loin width, there was a relationship between how muscle soreness, how sore the horses were, and their cannon bone and their loin width. Again, so far, I'm not seeing anything really that I'm like, that doesn't seem right. All of this is pretty standard known stuff. But a lot of times what you're going to find in these scientific studies is it's not necessarily the study itself that's like, that data doesn't work. It's the conclusions that they've drawn. Their data does not match the conclusions that they're trying to draw. And that's what we're going to see down in this discussion area. So in the discussion area, they acknowledge that this is the first study of its type, which is true. They used a subjective scoring system of, or an objective scoring assessment of muscle soreness and tightness in variables of body weight, horse height, cannon bone circumference, and loin. Notice now that they're putting in the horse's body weight as a variable. So now we're back up in the abstract, and notice to answer the question of whether horse height, cannon bone circumference, and loin width, they have now added in the horse's body weight as one of these factors. So they didn't add the horse's body weight into this factor until the discussion section, which is, I would say it's a yellow flag. If you are finding that there's another variable that seems to be influencing, then yes, absolutely, you can add it in, but you have to address that specifically, that this was not originally intended or designed to use body weight as a variable, and we chose to add it in because of X, Y, and Z. We are starting in on the discussion portion of this study. Up until now, there's been no red, yellow, or orange flags. Everything's looked good. We just discussed the yellow flag of the fact that in the first sentence, well, to our knowledge, that's the first sentence, that's great. But then they added in a variable that they did not discuss in the introduction and the abstract, which is the horse's body weight. They initially were only looking at the relationship between horse height, cannon bone circumference, loin width, and whether or not you could use those three variables to give you an idea of what a horse's carry weight capacity is. They have now added in the horse's weight, the body weight of the horse, which was not a factor that they had initially intended to study, as evidenced by the fact that it's not mentioned in the abstract or the introduction. I said this was a yellow flag because the issue is not that they added in a variable. Sometimes that happens. It's the fact that, as you'll see, they do not talk about it. The correct way of handling this would be, while we initially did not intend to study the horse's body weight, in addition to these other variables, we found that it was important and we decided to add it in due to X, Y, and Z. They didn't do that, so that's a yellow flag to me. So, the maximal mounted standard exercise test of the current study was designed to simulate a 45-minute working session of an intermediate riding lesson horse. All horses were successfully completed all exercise periods. One horse had to be removed after exhibiting lameness at the end of the trotting session of the last exercise testing period. So they talked about how in their study, they just kind of re-summarized everything that they did in this study, which was plasma lactate, creatine kinase, serum creatine kinase. Sorry, everyone, had to untongue-tie myself. But essentially, they're just summarizing what they did that we've already talked about up above. They're also referencing why they chose to do a leaded test instead of using different sized mounted riders, and that's because a study done previously had showed that horses didn't seem to react differently to mounted riders versus different sized mounted riders versus one mounted rider and then additional lead added to the saddle to increase the weight. Horses seem to respond the same way, so removing the variable of different riding styles and riding ability can be done by using added weight instead of different riders of different weights. I hope that makes sense. And so they opted to remove those variables by using 3 riders and adding weight, so that the horse for each of the treatments was ridden by probably the same rider with different weights. That was why they chose to do that, because this prior study had showed that the horses would react the same way either way. And that study, though, they mentioned only used between like 12 and 16% of the horse's body weight. Sorry, I had to make sure I knew where I was in this study. Yeah, so they did not notice a difference between plasma lactate heart rate at 15 to 20% of the horse's body weight. So there wasn't really a difference between the plasma lactate and the heart rate when the horse was carrying 15% of their body weight versus 20% of their body weight. They did notice a difference in the creatine kinase activity, carrying 15% versus 20% of their body weight. There's an important note here. I'm going to make myself bigger to give you this note. Okay. There's an important note here. So they talk about how creatine kinase, serum creatine kinase, is used to indicate muscular skeletal muscle damage in horses. It's also used to indicate skeletal muscle damage in humans. In fact, it's the same thing when you hear people talk about you work out, you get little micro tears in your muscles, and then they heal, and that's how you build muscle. That's the skeletal muscle damage they're talking about. They're not talking about injuries or lifelong damage or negative damage. The skeletal muscle damage that creatine kinase is generally associated with are those micro tears that lead to muscle building. Now, obviously, if you have a lot, like an over amount of creatine kinase, that can be indicative of an injury. But that's not what they're talking about. They are talking about, they would have said that. Like, that's something that you would need to specify in this study. So, the creatine kinase, what's a yellow flag about this to me, and I'm just going to say that it's a yellow flag, is the way that they're phrasing it is specifically being phrased, I feel, in a way that elicits emotion. They're saying, oh, this is skeletal muscle damage. Those words have a specific sense and feeling, which is, oh, this is terrible. We cannot let our horses have any release of creatine kinase. When in reality, the skeletal muscle damage that they're discussing in this is actually the ones that help build muscle. You will have to have some amount of skeletal muscle damage in humans, in horses, in many animals, to build up muscles. The horses will not build up muscle and will not be conditioned without some amount of skeletal muscle damage. And that's the type of skeletal muscle damage that they're talking about. But they're choosing vocabulary and a way of phrasing and a lack of clarifying what this means in a way that elicits a negative emotion. So that's a yellow flag for me. Then they go on to say, there was another study done by Wolfinger et al. We're about, 3/4 of the way down, a little more than that. Indicated that a plasma creatine kinase activity of 2-fold above resting corresponded with a negligible amount of skeletal muscle damage. Whoop, there it is. That's the part that they're talking about. They're like, this Wolfinger et al. Is indicating that a plasma creatine kinase activity 2-fold above what is the standard amount in their bloodstream at resting causes a negligible amount of muscle skeletal damage. Those would be the micro tears that build muscle. So we've already done a study on horses that indicates that creatine kinase, the serum creatine kinase that they just said is causing damage, is actually not causing that much damage. It's just enough to build muscle. So here's my next yellow flag. Then they go on to say, adding other factors such as muscle soreness and tightness may be important in determination of weight carrying ability. So the way that they're phrasing this is basically, yeah, we've already seen a study that says it's not really a problem, but we don't agree with that because the horses are sore. Yes, muscle building is often a sore process. If you do it in certain ways, you can avoid soreness, but generally the first couple of times that you start working out, just like these horses, you haven't worked out in 4 months, you're going to go to the gym, you're going to work out, you're going to be sore the next day. That's pretty standard. That's essentially what they showed in these horses. The horses didn't work out for 4 months, they got in a good workout, and now they're sore. Yes, that is totally normal. But they're trying to claim that that has to do with the weight carrying capacity of the horse. Do you notice that? Indetermination of weight carrying ability. So once again, we're coming back to the abstract because the question was not what is the weight carrying capacity of the horse. The question wasn't even how do we determine the weight carrying capacity of the horse. The question was, is there a relationship between cannon bone circumference, loin width, and horse height and their carrying weight capacity? That's it. It's not how do we determine it? How do we use these things to determine the carry weight capacity? The question was, is there a relationship? But now we go back to the discussion. And all of a sudden their discussion is how we can use muscle soreness to determine the weight carrying capacity of a horse. That was not the question. They seem to have switched questions on us. Initially the question was, is there a relationship between cannon bone circumference, loin width, and horse height and the horse's carrying weight capacity? The question was not, how do we determine the horse's carrying weight capacity? the question wasn't even how do we use cannon bone circumference, loin width, and horse height to determine carrying weight capacity. And the question certainly wasn't what is the carrying weight capacity of horses. The question was, is there a relationship between cannon bone circumference, loin width, horse height, and carrying weight capacity? But now all of a sudden in the discussion section, we're using phrases like other factors such as muscle soreness and tightness may be important in determination of weight carrying ability. We haven't even discussed that. Okay, moving right along. So then we get to creatine kinase activity was greater immediately after exercise when horses carried 30% of their body weight and remained elevated at 24 and 48 hours after exercise. Pretty normal standard. Again, you're going to be sore for a couple days after your first big workout in 4 months, which again is essentially what these horses did. They did not work out for 4 months. They did a big workout. Greater work rates, along with the increased plasma lactate concentrations found when horses exercised at the higher workload of 30%, are useful information to consider when combined with the greater levels of muscle soreness and tightness changes at 24 hours post-exercises when horses carried 30% of their body weight. They acknowledge that in humans, muscle soreness develops approximately 24 hours and may linger for 48 hours after exercise. Then they finally get into the relationship of loin width change in muscle soreness and tightness shows promise, with a negative correlation shown at the 25 and 30% range, suggesting that horses with wider loins experience less muscle soreness after exercise when carrying a heavier load. So we're finally answering the question, which is that yes, there is a relationship, and the horses that had wider loins seem to experience less muscle soreness. So yes, there does appear that the wider loins of a horse, that the wider the loin area of a horse, there's a chance that they can have a higher carry weight capacity. That can be used, that shows promise in being used as an eventual confirmation point when looking for a horse. Okay, now we're going to talk about the limitations. So this part's important because for me, the changing of the question and the fact that we have now spent probably 2/3 of our discussion area answering a question that the study did not ask in the abstract in the introduction or in the development of how the study was put together is an orange flag. It's more than a yellow flag because they didn't address it. It's not really a red flag exactly, because it's not like the end of the world if you have a question, design a study, and start the research process, and as you're analyzing the data, you realize that the data points you in a different direction than what you thought. That happens. And it is okay to address that within the study itself, in the discussion area. That's fine. But you have to acknowledge it. You have to acknowledge this study was not intended, you have to acknowledge it in some way. Something along the lines of this study was not intended to investigate A, B, and C. The study was created to investigate X, Y, and Z, but during the process, worthwhile data towards A, B, and C were found, and the investigations continued in that way because of, whatever, D, E, and F. They don't do that. They just change the question and then spend 2 sentences answering the original question and don't talk about why they changed the question or what data we're seeing there. Okay. Or what data led them to say, this is another interesting way to go. They don't address that at all. They just change the question on you without any acknowledgement, which is a huge orange flag. Because this study is not designed to answer the question of what is the carry weight capacity of horses, nor is it designed to answer how do we determine the carry weight capacity of horses. It is, again, not even designed to answer the question of how can we use cannon bone circumference and loin width and horse height to determine the carry weight capacity of horses. None of these questions are what the study is designed to answer, so this study should not be able to answer those. they may have found possible factors to answer those questions, in which case, again, if they acknowledged we found A, B, and C, and etc., it would be a yellow flag, but they didn't, so it's an orange flag. Okay, that was a lot of talking. Sorry, guys. Got a little soapboxy there. I hope it makes sense. So now we're getting into the limitations of the study, which is going to affect how we feel about that orange flag that I just talked about. Okay, so moving into small number of horses used in the study. That's a limitation. They only used... The small number of horses is a limitation. They only used 8 horses. Okay, perfect. But wait. Given the small number of horses used in the study, the results would follow in accordance with the load not excess of 20% of the horse's body weight for light riding horses. Whoa. Why are we talking about a recommended carry weight capacity for light riding horses when none of the data suggests anything like that? Again, this study is not designed to answer the question of the carry weight capacity of a horse. All we want to know is if there's a relationship between cannon bone circumference. I'm going to say this a bajillion times because that is the crux of why this study is kind of a problematic thing to be referencing in this case. The study was not designed to talk about the carry weight capacity of the horse. If we look at the data back in the results section, what they actually found was that horses showed signs of good exercise, or of a moderate amount of exercise, at 25 and 30%. Let me rephrase. Unconditioned horses, because they were off for 4 months, unconditioned horses showed signs of moderate exercise at 25 and 30% of their body weight during... So what they actually found was that unconditioned horses, after 4 months off, unconditioned horses showed signs of moderate exercise at 25 and 30% of their body weight for 45 and a 45-minute workout. That's what they found. And somehow they're getting the 20% recommendation out of that after already summarizing prior studies that indicated that up to 30% was totally fine for 100 miles. And that the serum creatine kinase at twofold of the resting amount only was indicative of like negligible musculoskeletal. So this recommendation just comes out of nowhere, and that's a huge red flag for me as far as bias goes. Because this recommendation does not match the data that they found, nor does it match the study. And I think I'm going to talk about that, and I'm already at 8 minutes, so I might have to talk about the importance of the study question versus the results that you get in part 5. But this is a red flag for me. It comes out of nowhere. And then they acknowledge, although strong correlations were not demonstrated, loin width as a potential indicator for weight carriage warrants further investigation. Loin widths and cannon bone circumferences obtained in the current study represented a much narrower and more heterogeneous group than expected, so they didn't see as much difference between the cannon bone circumference and loin width amongst horses to actually get a really solid study on it, as in all of the horses were a little too close together than they thought. Further, so that was another limitation to the question of cannon bone loin width and height, is that the limitation is that this study did not have as much variation between the horses' widths to get a good idea of whether or not it was a significant indicator. And then they also say that they need a larger population of riding horses, and further review of the usefulness of serum creatine kinase activity and its relation to muscle soreness. And so anyway, they're acknowledging the limitations to their study in regards to the circumference bone, the cannon bone circumference, loin width, and horse height include the fact that there wasn't really a big, huge difference between the the horses that they used, their circumference and loin width, so it was really hard to say whether or not that was impacting the differences, were actually pretty small. So they're saying that the more horses need to be used, only a study of 8 small population, so more horses and more variety in the loin width, and things like that. And then also, they say that it would be more studies reviewing the usefulness of serum creatine. They mentioned that another study had shown that serum creatine kinase really is negligible at a certain amount. So, is that really the best method of judging how much exercise a horse got? And what that exercise was bad for? And that's a keynote whether or not the exercise was bad for them. Because exercise on some level is going to be good for all animals. And then you reach a point where that exercise is no longer good, and it's causing injury. We don't really know where that is for horses, is essentially what they're saying. Or at the very least, we don't know how to judge on an objective scientific level where that line is. They chose to use serum creatine kinase and muscle soreness tests. They also suggested that hoof size might matter in there too. But they acknowledged that that might not have been the best way to go about, and more research should be done. If you guys see where I'm going with this. But they did not mention any of the limitations that happened to the recommendation of the 20% of the horse's body weight as its carry weight capacity. They made that recommendation and then didn't point out any to how their study might not have been the right study to make that recommendation with. That is also an orange flag, so. The way that you design your study, the results that you get from that, the conclusions that you draw from those results all matter. So in this case, as I've said a bajillion times by now, the question was, does cannon bone circumference, loin width, and horse height have a relationship to its carry weight capacity? That was the only question that the study was designed to answer. Why does it matter, and why does this design not answer what the carry weight capacity is? That's what I'm going to talk about in this final part. So to judge whether or not there's a relationship between those 3 factors and the carry weight capacity of a horse, you do not need to know what the carry weight capacity of a horse is. It doesn't matter. And that's why the study was very well designed to answer the question that it posed. Because they were able to design a study in which they took out the conditioning factor. How conditioned is the horse? That is a factor or a variable. That's a variable. In the study, they took that out by using unconditioned horses, by having them on 4 months of pasture rest. So at that point, all they were really looking at is if horses with a wider loin and a larger cannon bone circumference and a taller height, did those horses have less plasma lactate, less serum creatine kinase, and a lower heart rate when worked out after 45 minutes at the varying weights? And for the most part, they found that, yeah, the horses with the wider loins and the larger cannon bone circumference had less of a reaction that indicated a moderate workout than horses that had narrower. That's what this answered. The reason why it doesn't answer the carry weight capacity question is because when we're asking about carry weight capacity, now we do need to add in the variable of the condition of the horse. The condition of the horse, that we're just trying to look at one specific aspect, or well, 3. very small aspects of a horse's conformation. But now we have to add in the condition of the horse. We have to add in the skill level of the rider. We have to add in the rest of its conformation. And there's a lot more variables that go into the discussion of what the carry weight capacity of a horse. And again, the variables that they chose to judge the moderate exercise of the horse was perfectly fine for this, because we didn't actually need to know how much of a workout the horses got. We just needed to know how much workout they got in comparison to other horses of a different loin width and cannon bone circumference. We did not need to actually judge whether or not they got a good workout, or if it was too much of a workout. They did not need to figure out where the workout capacity was. Again, it was a 45-minute workout. It was intended to simulate a 45-minute intermediate rider lesson. But once we're actually discussing the carry weight capacity of a horse, we have to consider the length of the workout, the amount of the workout, the rider skill level. There's all these variables that need to be added in, and so they eliminated all of those variables because their question wasn't about the carry weight capacity of the horse. It was about the potential to use those three factors as a potential identifier for the carry weight capacity of a horse. I hope that makes sense. So, the fact that they're going to take and have a recommendation on this 20% rule when nothing about their study and the way that it was set up was intended to answer the 20% rule. They didn't even ask it in the beginning. They briefly referenced it in the introduction in relation to prior research. It just wasn't in the abstract of they threw that out in the end, and then didn't talk about how their study and the way that it was created to answer an entirely different question. They didn't talk about those limitations, of which there was a lot of variables in the carry weight capacity of a horse that we did not study in this research. So, no, we cannot make a recommendation on the carry weight capacity of a horse. We can say that more research can be done, and the exploration of carry weight capacity and indicators of a horse's potential carry weight capacity. And that's what they should have been talking about. To me, reading the study, that is a huge amount of bias that is coming through. And it's not the type of bias that they would necessarily report. Like a lot of studies at the end will have a declared biases on there. And then they'll write down what their declared biases, and they aren't necessarily biases that they're going to declare, but the fact that they added in all of this in, to me, shows a huge bias, and I think kind of colors the rest of the study and the validity of the study for me, because they drew conclusions that were absolutely not addressed at all in the study, did not list the limitations to the addressing of those conclusions. So I'm going to repeat that a little bit clearer. They drew conclusions that the study was not designed to answer, did not list the limitations to the potential of drawing those conclusions, based on the fact that their study was not designed to answer that or to draw those conclusions. And then, the data from their study doesn't even back up the conclusion that they drew. Because, again, the data showed that 25 to 30% of an unconditioned horse for 45 minutes shows a moderate level of exercise. And I'm saying moderate. I would argue that it's a mild level of exercise, but others would disagree, so I'm just going to go in the middle and say moderate. So the conclusion that they drew isn't even backed up by the data that they got on the study that was not designed to draw that conclusion. And the whole thing is a huge red flag. So,